Good day, students, and welcome to the day 2 of our first week for the second quarter. And for this week's lesson, we will be dealing with note number 6. Explain how quantum mechanical model of an atom describes the energies and positions of electrons. And here is the lesson objective for today. At the end of the lesson, you are expected to describe the set of quantum numbers and complete the given set of quantum numbers for each given element. Today, we will be dealing with quantum numbers. Quantum numbers specify the layout of an electron's possible position in an atom. An electron in a given atom or ion has four quantum numbers to describe its state. Every electron in an atom has a specific and unique set of these four quantum numbers. These quantum numbers indicates how electrons are located or the possible location of electrons around the nucleus and its movement. Quantum numbers indicates the possible location of electron and its movement around the nucleus. The first quantum number is the principal quantum number that signifies the mean energy level. On our past discussion, energy level is the orbit or shell where electrons are possibly located. The second one is the angular momentum quantum number that specify the shape of an orbital with a particular principal energy level. If you will remember, on our past discussion, we have four sublevel or orbital, the S, the P, the D, and the F. So angular momentum quantum number indicates these sublevels. The third one is the magnetic quantum number that describes the number of orbitals within a sublevel. If you will recall our past discussion, we can say that S orbital have one orbit or one orbital, P sublevel have three orbitals, D sublevel have five orbitals, and F sublevel have seven orbitals. So those numbers of orbitals per sublevel is being indicated on the on magnetic quantum numbers. And last one is the spin quantum numbers. This one indicates the movement or the spin of a given electron. Now, to formally or to explain further the different quantum numbers, let's start with the principal quantum number. Principal quantum number signifies or represented by letter N. It is the mean energy occupied by the electron. Energy level are fixed distance from the nucleus of a given atom. They are described in whole number increment, such as 1, 2, 3, 4, 5, 6, and so on. At location 1, or n equals to 1, it indicates the first orbit, or the orbit closest to the nucleus. So electrons located on n1 is the electron located on the first orbit from the nucleus, while electrons at n2 are electrons that are further from the first orbit. Then n3 more further from the first orbit or from the nucleus. The principal quantum numbers also corresponds to the rows for an atom on the periodic table or the what we call the period. So as an example for quantum number we have here. So let's say an electron is located on N2. It means that this electron is located on the second orbit from the nucleus, or in short, it is located or this electrons is located on the second period of periodic table. Next quantum number is the angular momentum quantum number that signifies as L or represented by L. It specifies the shape of an orbital with a particular principal quantum number. The value of angular momentum depends on the value of the principal quantum number. The angular momentum quantum number can have positive values of 0, 2, and minus 1. So if we have principal quantum number 2, the angular momentum quantum number could be either 0 or n minus 1 equals to 1. So if we have n is equals to 2 minus 1, we will have 1. So we have two kinds or two angular momentum quantum numbers for n equals to 2. So it indicates the sublevels. So if you will remember for the second period, we have two sublevel, the sublevel S represented by 0 and sublevel P represented by 1. So it is true that on the second principal energy level, we have two sublevels, the S and the P. Next quantum numbers is the magnetic quantum numbers that signifies as letters ML. It describes the number of orbital within a sublevel. On our previous discussion, we will recall that S sublevel have one orbital, P sublevel have 3 orbitals, D sublevel have 5 orbitals, and F have 7 orbitals. And these orbitals on every sublevels is being represented by the magnetic quantum numbers. Let's have an example. The principal level is 2. It means that an atom or an element has an electrons on the second orbit. The angular momentum quantum numbers are 0 and 1. Remember that the angular momentum quantum numbers are 0, 2, and minus 1. So in this case, we have 2. So 2 minus 1, we have 1. So from 0 to 1. While the magnetic quantum numbers is being represented by the following quantum numbers or by the following sublevels. So for the angular momentum 0, we have a magnetic quantum numbers as 0. While for the angular momentum quantum numbers, we have 1, and the magnetic quantum numbers are positive 1, 0, and negative 1. Remember that the magnetic quantum numbers is consist of the positive and negative version of the angular momentum quantum numbers together with the 0. Last quantum number is the spin quantum numbers. It describes the spin or the movement of a given electron in an atom. Electrons can have one of the two associated spin, either upward or positive 1/2 spin, or downward negative 1/2 spin. An electron cannot have zero spin. It means it is moving. We also represent the spin with an arrows. It's either upward or downward. A single orbital can hold a maximum of 2 electrons, and each electrons on the orbital must have the opposite spin. Now, to determine the spin quantum numbers, we will use the electron configuration of an atom. Let's say, for example, the boron 5. It consists of 5 electrons on the atom of boron. So, if we will write the electron configuration for boron, we will have 1s2 that consists of 1 orbital, 2s2 that consists also of 1 orbital, and 2p1 that consists of 3 orbitals for the p sublevel. Now, each orbital must consist of a maximum of 2 electrons. So for the 1s2 or 1s sublevel, it consists of 1 electron that is moving positive 1/2 spin and another electron that is moving negative 1/2 spin. So both electrons or the electrons present on the 1s move on different direction. On the 2s, we have a maximum of 2 electrons, and both of these electrons are moving differently from one another. Then on 2p, although they have 3 orbitals, only 1 electron is present. As you can see on this representation, it is always starts with a positive 1/2 spin, while the other electron present on this orbital must be opposite to another. Now, to sum it up, let's have an example. So let's say we have the neon 10 that consists of 10 electrons. So how the 10 electrons is being located around the nucleus and how they are moving. So we will use the quantum mechanical or the quantum numbers. So here are the electron configuration for neon: 1s2, 2s2, and 2p6. The first quantum number is the energy level. It is represented by the whole number before the letter. So for the 1s2, we have a energy level or principal energy level as 1. For 2s2, we have energy level 2. On 2p6, we also have principal energy level 2. Next quantum number is the angular momentum quantum number that consists of 0 or starts with 0, 2, and minus 1. So in this case, Rn is 2. So it starts with 0, then S minus 2. So n minus 2 is 1. So for a quantum number for the principal energy level, we have 0. For the second principal quantum number, we have 0 and n minus 1, which is equivalent to 1. The next quantum number is the magnetic quantum numbers. It consists of the positive angular quantum number, 0, and a negative angular momentum quantum number. So in this case, for the first or the energy level 1, because we have only 1, so the magnetic quantum number is 0. While for the principal energy level or principal quantum number 2, we have positive 0, 2, positive 1, and negative 1. Now, for the last quantum number, which is the spin quantum numbers, we just put 1 positive 1/2 and 1 negative 1/2. Now, as you can see, every electron have different quantum numbers. So the first electron present on the first principal energy level is consists of this set of quantum numbers: 1 principal quantum number, 0 angular momentum quantum number, 0 magnetic quantum number, and positive 1/2 spin quantum number. The other electron present on the first orbit is consists of these sets of quantum numbers: 1 for principal quantum number, 0 for angular momentum quantum number, and 0 for magnetic quantum numbers, then negative 1/2 for the spin quantum numbers. Now, if you will observe every electrons on each orbital in every sublevel, they all have different number or quantum numbers. It represented that every electrons present on an atom have different location, different motion. So each electron have different characteristics, and that is what quantum numbers want to imply. There is only a probability that an electron can be found on a specific area around the nucleus of an atom and how they are moving. So that's it for our lesson for today. You can now proceed to your task activity.